Okay, Math 9, here we go. We are going to be working on algebra, or as I like to say, equation manipulation, because that is really the important part. The answer is almost pointless, and I'll explain more about that in a minute. So let's get after it. Here we go. So first thing we need to consider is the equal sign. It's super important. Before the equal sign, we didn't have a level of parity between the left and the right. And what it does is it allows us to change and adapt the given equation as long as we do the same thing to both sides. We maintain balance because 4 equals 4, as you see here, those sides are balanced. So what we can do is we can do things to either side as long as we do the same thing. So if I added 4 to the left side, or added 2 to the left side, they're no longer balanced. So what do I have to do? I have to add 2 to the right side. If I subtracted 2 from the left side, I would have to subtract 2 from the right side because they're not going to be balanced if I don't do the same thing. You can bring that into multiplication as well and division, but we'll get to those as this video progresses. But here it's like, well, if I multiply this side by 3, I have to multiply this side by 3 because otherwise I'm not maintaining balance. So we have to make sure that that is always our focus. Whatever we do to one side of the equal sign, to each term on it, which we'll get into, you have to do to the other side. That is how you manipulate the equation. It's not just about moving things around or figuring out the answer. It's about how do we move things around and how do we do it logically so that we're allowed. So here's some common errors with respect to the equal sign. Now 5 plus 2 isn't an error, but what people do is they'll go, oh, 5 plus 2 is 7. And then plus 2 is 9. And then, oh, minus 4 is 5. And plus 1 is 6. And they'll write out a stream of consciousness like this. But this is a big issue because this is completely false. Because what this says is it says that this statement here is equal to this statement here. And 5 plus 2 is 7. And 7 plus 2 is 9. So those aren't equal anymore. I mean, yeah, 7 plus 2 is equal to 9, but it isn't equal to 9 minus 4, which is 5, and then 5 plus 1 is 6. So you end up with a statement that technically says this: 7 equals 9 equals 5 equals 6 equals 6. That's not even close to true. So do not use equal signs as a stream of conscious thought. What you should do is you should be organized and clean with what you're doing and go, okay, 5 plus 2 is 7. And then if you're doing a new thought, start a new thought. 7 minus 2 equals 5. If you wanted to continue a stream of thought horizontally, you could go, okay, 5 plus 2 equals 7. And then do an arrow and start your next thought. 7 minus 2 equals 5. What you're doing is you're not abusing the equal sign. The equal sign is really, really important, and you cannot take it for granted. So no streams of conscious thought written down, okay? Bad, 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 bad. Don't do that. So let's look at what you probably all think of as algebra, which is how are we going to manipulate the equation? Now, you might be able to look at this question, x plus 4 equals 7. So that means something plus 4 equals 7 and think, well, that's easy. It's 3. And honestly, I hope that that's easy. But the goal behind algebra is not just getting the answer. The goal behind algebra is manipulating the equation logically, okay, manipulating, following all the rules, so that the variable tells you what it is. So you're isolating the variable. You're getting the variable all by itself. So at the end, the variable says, I'm equal to blank. So how do we do that, right? That's what we're going to look at on the next couple slides. So the first thing you want to look at is the addition principle. So the addition principle states that we use addition or subtraction. And yes, you're probably thinking it's the addition principle. Why isn't it the subtraction principle? Because as I mentioned in an earlier video, if you subtract two numbers, that's just the addition of a negative number. So addition covers it all. But the goal here is whatever we're doing to the variable, you can see in this case we have r minus 4, in this case we have q plus 5, and in this case we have t plus 5. The goal is to end up with 0 on the side with the variable, right? We want r plus 0, we want q plus 0, we want t plus 0, because that's just r, q, and t. So how do we get to 0, right? In the addition principle, we are trying to get to 0. So look at what is being done to the variable. In this case right here, I am subtracting 4. So how do I get 4 negative? So remember the sign in front of a number belongs to the number. So how do I get that to 0? Well, I'm going to add 4. because what's negative 4 plus 4? It's 0, right? But what I do to the one side, I have to do to the other side to maintain balance. So what I get here is I get r plus 0, and you're going to see in a minute I'm going to stop writing that, equals 7 plus 4. So r equals 11. We've got to a point where the variable is telling us what we are. So let's look at the next two. You have q plus 5 and you want 0. How do you get it? You need to subtract 5 because then you just get q because 5 minus 5 is 0. But then we have to do it to that side because we need to maintain balance. And on the last one, again, we are going to subtract 5 and subtract 5, so 0. And t equals, well, what is 2 minus 5? And that's the thing, right? If you were subtracting 5 from that side, that's the same as saying 2 minus 5. So we get negative 3. So those are the most basic steps. Our journey through algebra is going to take us on a staircase, and we're going to get to the top level, which are quite confusing. But if you break them down into individual steps, this one being the easiest step, you'll see that it gets easier and easier and easier looking at piece by piece. So here is a scenario where we can still use the addition principle. When we get to the multiplication principle, you'll see another way to view this. But it's in consideration of your variable. Now here my variable is negative. So if, for instance, you were to say, okay, I'm just going to go on autopilot and I'm going to subtract 4 because I want r alone, and I'm going to subtract 4. Now you have negative r equals 3. And the thing is I don't want to know what negative r is. I want to know what positive r is. So when we get to the multiplication principle, I'll show you a way to deal with this. But let's look at this another way, because it's important to understand that you can eliminate variables from one side of the equation as well. Let's just say I don't want that negative r. I want 0. So I'm going to add r, because negative r plus r, 1r, right? R is something. If you have negative of them plus something is 0. So then I'm going to add r to that side. So I get 4 equals 7 plus r. You can see my r value is now positive. So now I need r alone, so I'm going to subtract 7 and subtract 7, and I get negative 3 equals r. So you can move the variable from one side to the other by adding or subtracting. So if we look at the next one, you have negative t there, right? 5 minus t right here. So let's get rid of that negative t because we don't want it. So how do we do that? Well, we just add t, just like we would with a number. So we add t, and then we add t, and we get 5 equals t plus 2. And now last step, subtract 2, t equals 3. So we are done. Now we're going to look at the multiplication principle. So for the multiplication principle, what we are looking at now, the magic number isn't 0. We're not trying to get to 0, because getting to 0 would just give us 0, right? If we multiply by 0, we get 0, and that doesn't help us. Even if we multiply a variable by 0, well, we're still going to get 0, and we don't want 0 of our variable. We want 1 of our variable. We want to know what 1 of our variables is worth, right? We don't want to know what 3r is worth. We want to know what 1r is worth. So how do we get to 1? Well, we use division or multiplication. And it's always look at what you're doing to the variable and then do the opposite. So here it's 3 times r. So how do we get back to 1? We divide by 3. So we divide by 3, because what's 3 divided by 3? 1. So we're left with r. But again, we got to do the same thing to both sides. So r equals 3. If you have a negative number in front of your variable like this one, that's negative 5 times t. Well, we're just going to divide by negative 5, because a negative divided by negative is a positive, and a 5 divided by 5 is 1. So we get t, but we need to divide this side by negative 5. Don't forget that. So 25 divided by negative 5 is negative 5. And then the last one, this might seem like, what is going on here? But remember that we don't write 1s in front of our things here, right? This is 1r, and this is 1t, but we don't write that. It's just a little redundant. So if you have nothing in front of your variable except a negative sign, well, you have a negative 1 times x equals negative 2. So you get two options. You can divide by negative 1, because that's going to give you the negatives cancel, and 1 divided by 1 is just 1. Or you could multiply by negative 1 on both sides, because it's the same result. Negative 1 times negative x, the negatives cancel, 1 times x is still x. So x equals 2. So when you have just a negative in front, multiply or divide by negative 1. And that's that extra piece for a negative variable that we looked at in the addition principle. So there's some examples in your notes to try, but consider that. And I'll do one here in a minute for you. So let's look at a couple more. Well, I am going to divide by negative 3 and divide by negative 3. So I end up with 3's cancel, negatives cancel, r equals, well, 11, a positive number, 11, divided by a negative number, 3, is a negative answer. And I just have 11 over 3. Fractions are numbers too. Treat them as such. That's a lovely answer. R equals 11 over 3. It's not always going to be a perfect whole number or integer. Divide by 4, divide by 4. T equals 13 over 4. Be okay with that. Be comfortable with that. And then here, divide by 2, x equals 1. So look at what you're doing to the variable and do the opposite. If you're multiplying the variable, you divide. If you're adding to the variable, you subtract. If you're subtracting from the variable, you add. So then what if you're dividing with the variable? Well, the opposite is multiplication. And I want you to look at what this is, okay? This is 4 over 1 times r over 4. And if you remember how we simplified fractions, if you have a common factor top and bottom, they will just cancel each other out. So that's what's going to happen here. The 4 cancels with the 4. Because it's like saying 4 times r over 4, but it's just a redundant step. If you have a factor on top that will cancel with the bottom, it works. So then multiply by 4 and you get r equals 4. We're going to multiply by 5. 5 cancels with 5. Multiply by 5, t equals 35. Multiply by 4. Multiply by 4. X equals 48. So those are our one-step questions. Those are the ones that hopefully at the end are going to be the easy one. You'll get to that point and you'll be like, yes, I'm almost done. This last step is easy. So what happens if we have multiple steps? So we're going to see some questions that have probably 5 or 6 steps, but these ones here just have 1 or 2. And the idea is still the same. Get the x variable to tell you what it is, which means x equals what? Well, what we're going to do is we're going to get rid of the plus 5 first, because it doesn't make sense to divide by 2. And I'll explain, because if you divided that by 2, sure, those are going to cancel. But you would have to divide that by 2 and divide that by 2. You have to divide everything by what you're doing, otherwise you're not keeping that balance. And then all of a sudden you've created a bunch of fractions to deal with, and that's not really enjoyable. So what we'll do first is we'll subtract 5 from both sides. That's step 1, because now I have 0 there. So I have 2x equals 1 minus 5 is negative 4. And now I do my division. Divide by 2, x equals negative 2. X is telling me exactly what it is. That's the algebra. So next one, I want to get rid of that negative 6. So I'm going to add 6 to both sides. And negative 3r equals 15. Divide by negative 3, divide by negative 3. R equals negative 5. So 2 steps to those ones there. Okay? Couple more. Now here's where I really want you to consider that it's about manipulation and not about what's the answer. Because as your math increases, we are going to quickly replace most of the numbers with letters, because we want to solve in the abstract so that we can use that for a generic scenario. So in this case, I want to know what a is. So I want the equation, I want a to tell me what it is. And there's nothing different here than what we did at the beginning. I don't want that plus b, all right? I don't want this here. I want that to be 0. Well, how do you get plus b to be 0? You just subtract b, because then it doesn't matter what value b has. If b is 5, you're doing 5 minus 5. If b is negative 3, you're going to add, right? So you're going to do b plus b. In the end, it's always going to cancel out. It's the exact same thing. So you end up with a equals c minus b. So a equals c minus b. So it doesn't matter what a, b, or c is. If you want to know what a is, as c and b change, it'll just spit out a value for a. So that's why this is helpful. Now, if we look at this one, we got a little bit more going on, but it's still only 2 steps. So first thing I want to get rid of is this is the one time we're going to see you getting rid of a variable, right? I don't want any b's on the left side of the equation. So I'm going to add 3b. I want to get to 0, and that gets me to 0. So I'm going to add 3b to that side. So now I have 2a equals c plus 3b. or you could say 2a equals 3b plus c. I just rearranged these two terms. You're totally allowed to do that. We like to do things in alphabetical order, but I'm not going to fret on that here. And then we just need to divide by 2. And what we have to do is we have to divide everything by 2. So now a equals c over 2 plus 3b over 2. And that is where we get to a little bit more of a high level. But we're just doing those steps we just talked about: addition principles, multiplication principle. So now, a few videos from now, we're going to look at multiple fractions, but here we're just going to look at one fraction. And there's two ways you can do this. And you can look at this as 2 over 3x means 2 times x over 3. So that is really helpful to consider. So what we have is 2 over 3x equals 4. So I'm dividing by 3, right? So how do I get rid of division? Well, I multiply. So I'm going to multiply by 3, because now the 3's will cancel, and I multiply by 3. So now I have 2x equals 12. And now we're down to a one-step question. Divide by 2, divide by 2. Boom. So x equals 6. Now I want you to look at here what we did. So I'm going to show you this in one step on the next slide. We multiplied by 3, and then we divided by 2. Okay? So what does that look like as one step? Well, we would multiply by 3 and then divide by 2. So we are multiplying by what's called the reciprocal. If you have a fraction, the reciprocal is the flipped version. And if you multiply a number by its reciprocal, you always get 1, because all the numbers cancel each other out, right? So if we multiply here by the reciprocal, we're going to get rid of that in one step. The 3 cancels with the 3, the 2 cancels with the 2. We just need to make sure we multiply that by the reciprocal as well. So we get x equals 12 over 2. Remember, that's a 4 over 1. We multiply tops to tops, bottoms to bottoms, which gives us 6. Multiplying by the reciprocal is super helpful, but be very careful that when you have multiple fractions, it doesn't work. So it only works when you have one fraction times your unknown equals one thing. Otherwise, it gets messy. Okay, so this is the scenario to use it, but I'd be very happy if you just did it in 2 steps. If you did it in 2 steps, that's great. Okay, it shows me that you understand how things are working out. So a lot of times when we do algebra, people are like, well, yeah, this is great. When am I going to use this? And from a high school standpoint, you actually use algebra without realizing it often. You just don't necessarily formulate the equation. The other aspect would be when you go to science or physics class in grade 10 or 11, your teacher's going to be real happy if you know how to do algebra. Because in physics, you have an equation here for force. Force equals mass times acceleration, right? M times A. And you can use algebra to solve for any other variable you want. So let's just say, well, I want to know what mass is equal to then. Well, how do you get M by itself? It's M times A. So you would divide by A and divide by A. So M is equal to force divided by acceleration. So now you have another equation for physics. If you didn't know what the mass was, you just take the acceleration and divide it from the force. Or if you had this, you could also isolate acceleration by dividing by the mass on both sides. So acceleration is equal to force divided by mass. So you use algebra to manipulate these given equations that people way smarter than me have come up with. We also have this. If you've driven in a vehicle before, you have undoubtedly known that you are traveling at a certain speed. And if you think about it's 50 kilometers per hour, right? That is a distance on top and a time on the bottom. So speed is equal to distance over time. And you can algebraically manipulate this equation to a whole bunch of different scenarios. Let's multiply both sides by t. Those cancel. So you get speed times time equals distance. So there's 1. If you have here, well, actually we've gotten to speed times time equals distance, and then let's divide both sides by speed. So now you also get that time is equal to distance over speed. So you have 3 things. You get speed is distance over time, and that should make sense, kilometers per hour. You get the time is distance over speed, right down here in the corner, and that should make sense because intuitively, how long did it take you to get somewhere? Well, it depends on how far you had to go and how fast you were traveling. And then the last one, speed times time equals distance. Intuitively, again, how far did I travel? Well, it depends on how fast I was going and how long I traveled at that speed. So all of these things are connected through algebra. So you're going to see it again often. So try your best to get as comfortable with it as you can. Thanks so much. Remember, this is supplemented for section 3.1 of the notes on my website. Keep on going. You're doing great.